Aerodynamic efficiency, not raw horsepower, is the primary metric by which the new king of the ring has been sculpted. While the powertrain team focused on the integration of the T-hybrid system, the aerodynamics department at Weissach was tasked with a far more contradictory objective: doubling the downforce coefficients of the previous generation while simultaneously reducing the drag coefficient in low-load scenarios to accommodate the higher top speeds required on the Döttinger Hohe. This vehicle is not merely a car. It is an active atmospheric manipulation device. The most visually arresting component of this philosophy is the active rear wing, which now adopts the swan neck mounting pylons first utilized on the 911 RSR. By suspending the wing from above rather than supporting it from below, we ensure that the airflow over the critical suction side of the airfoil remains undisturbed by mounting hardware, thereby maximizing the pressure differential. However, the static profile is secondary to its dynamic capability. The wing features a hydraulically actuated drag reduction system, DRS, derived directly from Formula One. In standard operation, the main plane and the adjustable flap operate at maximum attack to glue the rear axle to the tarmac. Upon activation, either manually by the driver or automatically, when the system detects sustained longitudinal acceleration above a specific threshold with steering angle variance near zero, the flap flattens within 200 milliseconds. This reduces total vehicle drag by approximately 30%, instantly converting the aerodynamic load into forward velocity. This is not a fixed aesthetic element. It is a variable geometry surface that breathes with the throttle. Working in concert with the rear wing is the completely redesigned underbody. We have moved beyond simple flat floors. The 2026 GT2 RS features a complex topography of Venturi tunnels that begin at the B-pillar and aggressively expand toward the rear diffuser. These tunnels accelerate the airflow passing underneath the car, creating a localized low-pressure zone that sucks the chassis down onto the road surface. This ground effect downforce is the most efficient form of grip generation as it incurs a negligible drag penalty compared to wing-generated downforce. To facilitate this, the rear diffuser strakes have been lengthened and deepened, utilizing the high-energy exhaust flow from the central exit pipes to energize the wake and pull the underbody air out more rapidly, a concept known as exhaust-blown diffusion. The most radical departure from traditional turbo lineage is the elimination of the lateral air intakes in the front bumper, a design necessity driven by the adoption of the central radiator concept. In previous iterations, the outer intakes fed independent radiators, which created turbulent air in the wheel wells, a disaster for lift generation. By consolidating the cooling into a single, massive radiator canted forward in the nose, we can now duct the hot waste air directly upward through the hood-mounted extraction nostrils. This serves a dual purpose. First, it prevents the hot air from being ingested by the engine intakes at the rear. Second, and more importantly, the exiting air is guided over the roof and directly onto the rear wing, effectively preconditioning the airflow for the rear active elements. The space vacated by the side radiators is now occupied by fully active aerodynamic flaps. These flaps are infinitely variable and controlled by the vehicle dynamics computer. Under heavy braking, they close completely to spoil the airflow and shift the aerodynamic balance forward, stabilizing the nose. During cornering, they adjust independently to channel air into the wheel arch vents, cleaning up the turbulence generated by the rotating wheel assembly. The chassis dynamics required to support this aerodynamic load necessitated a complete reevaluation of the suspension geometry. The front axle retains the double wishbone layout introduced in the 992 GT3, but the control arms have been profiled into teardrop airfoils to contribute to the downforce total, yielding an additional 40 kilograms of load at 300 kilometers per hour. Because the aerodynamic load increases with the square of speed, the spring rates must be stiff enough to prevent the car from bottoming out at Vmax, yet compliant enough to maintain mechanical grip in low-speed hairpins. To achieve this, we utilize the Weissach package magnesium wheels, which reduce unsprung mass by over 8 kilograms. This reduction allows the active dampers to react with higher frequency and precision, keeping the tire contact patch consistent, even as the vertical load on the car fluctuates by hundreds of kilograms depending on speed. The dampers themselves feature independent adjustment for compression and rebound in both high-speed and low-speed shaft movements, adjustable directly from the steering wheel rotary knobs. The interface between this engineering and the asphalt is the Michelin Pilot Sport Cup 2R tire. This is not the standard N0 spec found on the GT3 RS. It is a new N2 specification compound developed specifically for the torque vectoring characteristics of the hybrid powertrain. The rear tires have been widened to 335 section width to cope with the combined torque of the engine and the electric motor. The sidewall construction has been reinforced with aramid fibers to withstand the immense lateral loads generated by the active aero, which can exceed 1.8 GS in high-speed cornering. The compound hysteresis is tuned to operate at a higher optimal temperature window, recognizing that the hybrid system and increased vehicle mass will put more energy into the carcass during a qualifying lap. Finally, we arrive at the theoretical verdict regarding the Nurburgring Nordschleife. The current production record is held by the Mercedes-AMG 1, a vehicle that is essentially a Formula One car with a license plate, boasting a time of 6 minutes and 35.183 seconds. Our simulations suggest that the 2026 GT2 RS, despite a power deficit and a simplified aerodynamic profile compared to the AMG 1, achieves a theoretical parity in sector times. The Porsche's advantage lies in the consistency of its mechanical grip and the instant torque fill of the hybrid system exiting slow corners like Exmoor and Bergwerk. While the AMG 1 dominates on the Döttinger Höhe due to pure top-end power, the GT2 RS claws back time in the technical sections of the track through superior transient response and braking stability provided by the active aero balance. We project a lap time in the low 6:30s, potentially 6:33 to 6:34, depending on ambient conditions and tire degradation management. The king is not dead. It has simply evolved.